Electronic Specifier.
Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Axel Stoermann, VP and Chief Technology Officer at KIOXIA Europe. We chat about AI and edge computing. So, about 18 months ago, most people understood ChatGPT by name, but not yet by what it could do. Things have rapidly moved on since then. It's only one aspect of how AI can be utilised. AI is much more when it comes to cloud edge and endpoint applications and hardware-software scenarios. And within these deployments, the common denominator is data collection and the memory needed for new applications. Axel shares with us his thoughts on data traffic, memory selection, and security and data privacy concerns. We hope you enjoy this episode. Let's get started.
Electronic Specifier.
Hello everyone and welcome back to Electronic Specifier Insights. Today I'm pleased to be joined by Axel Stoermann, who is the VP and Chief Technology Officer at KIOXIA Europe. So hi Axel, thanks for joining us. How are you today? Are you well?
Hi there. I'm doing very well. So I'm really excited to go into further discussions now.
Yeah, no, brilliant. Thank you. It's a pleasure to have you. So why don't you start by telling us a little bit about yourself and your background?
Okay. Yeah, I'm, let's say, managing the CTO office at KIOXIA Europe. And I have a pretty long history actually around electronics and also especially AI. And that is also one of the big topics which we are focusing on as the market is really driven and accelerated by this kind of step-by-step AI implementations. So that is one of the major tasks of my day-to-day activity. Yeah. So, and basically I'm engineer and I have a long history also on AI and neural networks and started with image processing, also among building of supercomputers long time ago in the mid 90s. And it's quite interesting to see a déjà vu nowadays. So after more or less 30 years of activity in the industry from my side, I can see that AI and also neural networks and these kind of new activities are driving for new applications, new use cases, enable many applications as such. So it's really interesting that after such a long time, so basically, we can now, let's say, further develop and further expand AI in the industry.
Yeah, definitely. And that's exactly what I'd like to chat with you about today. But before we get into that, can you tell us a little bit more about the company as well? You know, what it is KIOXIA does?
Yeah. So KIOXIA basically exists since 2019. Actually, there's a much longer history around. So actually, the origin of KIOXIA is coming from Toshiba Corporation. This has a much longer history, more than 100 years. And so in 2017, actually, the memory activities which I'm dealing with were spinned off to Toshiba Memory Europe. And then 2 years later, we changed name and were getting independent. And now we are KIOXIA Europe and already celebrating our 5th anniversary this year.
Fantastic. Thank you. So let's dive into the topic, which is going to be around AI and edge computing. So around 18 months ago, most people understood and recognized ChatGPT by name, but weren't really sure, what it could do. But things have rapidly moved on since then, and it's really only one aspect of how AI can be utilized. AI is much more when it comes to cloud edge and endpoint applications and hardware-software scenarios. And within these deployments, the common denominator is data collection and the memory needed for new applications. And I understand that it's anticipated that data traffic will move to edge and endpoint. So I'm interested to hear which applications you're seeing and which we'll see more of in the future.
Yeah, well, that's completely right. I mean, AI is really on the table. And I mean, today's parallel HPC architectures like the powerful GPUs and also HBMs and high performance DRAMs are really driving to completely new horizons of AI implementations. And as I said, I have a history of tens of years in this area. And I started actually with this kind of AI type integration stuff on hardware level. But at that time, let's say technology was much poorer and was not really capable to enable very powerful and demanding applications as of today. And as such, the speed of the deployment of, let's say, ever new applications driven by existing and new use cases, I would say specifically in adding new and more powerful applications in the cloud, right? So this is more the central AI, which we see. And here, definitely the whole story started as I think also from the big hyperscalers and enterprise companies. We could see a lot of innovation and a lot of investment in the last years. And in fact, this is also the area where, majority of our business is placed nowadays. And so from cloud and from, as I said, more and more expanding number of applications which are centralized in cloud, step by step, we can see that this experience on AI-based applications is getting more and more popular and more interesting also in the so-called edge or even endpoint areas. We can see mobile phones are, let's say, changing shape and changing functions, changing features rapidly. And also here AI, which is then more the edge or endpoint AI, is utilized more and more. And then I would say another big area is so-called industrial automation or smart factory applications, where we also have to move from cloud into the edge or even into the endpoints. A lot of data has to be managed and computed locally rather than to move it into based on individual jobs into the center and then wait with long latencies to get the results in return. Because we have real-time applications at the edge, we have latency-sensitive requirements. So I think more and more we can see the migration from the established cloud, or let's say AI cloud applications into the edge more and more.
So what factors or investment in cloud, edge, or endpoint will this require, and where should companies put the focus?
I would say based on the growth of performance requirements and more powerful AI applications, I would say we can split the AI challenges in two parts. One is more or less the training of the models, and then the execution or inferencing of the models, which have different types of requirements. For example, for training, you need very high bandwidth. For kind of execution of or inferencing of individual models at the edge or at the endpoints, definitely the applications are running under real-time conditions. So here the latency has to be very low, which is a critical factor. And last but not least, it is a scaling of required storage space, which is sometimes limited nowadays, is still limited on the scale of a DRAM memory, which is still running at 2D or 2 dimensions. And it is also combined with HBM, which is more or less based on expensive chiplet and TSV packaging technologies. So it is really, I would say, big cost issue. So key for cost down and further improvements of required performance levels is also a link to reduction of idle time of GPUs, right? Mm-hmm. So that the GPU is focusing on the main tasks and not blocked by kind of maintenance and also housekeeping activities. So as such, new techniques like checkpointing on training or even offloading of data from DRAM to flash is on the table. And here we are getting in as a KIOXIA, as a representative of flash manufacturer, leading flash manufacturer. We are step by step trying to analyze the needs or the enabling of a flash and replacement in some areas from DRAM to flash on AI in future.
Mm. Perhaps you could tell us about the HPE Spaceborne case study, because I know that's a really fascinating facet of edge technology deployment.
Yes, in fact, we as KIOXIA went to space together with HPE and also based on other computers which were on a SpaceX mission beginning of this year. So that was quite exciting to observe. And for us, as you can imagine, this is kind of major opportunity to prove the quality and the endurance or even performance of our storage and memory products. So in fact, we had the pleasure to place our storage products on such kind of space computers. And in fact, after this mission, we could reconfirm equipment was running well. And I mean, we could prove that our parts up and running and could prove that, let's say, our technology is capable to run under space condition or outer space conditions.
Brilliant. What an excellent case study to be able to share with your customers. So with the demands on memory and data traffic growing exponentially, are there any particular challenges and requirements that you can see?
Well, yes, we have, as mentioned earlier, we have limitations, I would say, in especially memory technology, as we have requirements on further scaling of memory or let's say and computation power. And so also more and more we can see that, let's say, the scaling is also related to more and more powerful applications, like talking about vector databases for handling or carrying all the parameter data, which is necessary for inferencing of an AI model. And so here we have to consider how it is possible to scale DRAM more, but also, as I mentioned earlier, how to make it possible to utilize flash memory, which is much cheaper and can scale much more, can be a candidate to coexist next to DRAM and can be combined in, let's say, new kind of storage concepts to support not only the, let's say, execution of a program, but also to keep and hold the data, the warm and cold data, which is necessary to run the AI models on an application.
So what are the considerations when selecting the right type of memory? Is there an ideal one for all these applications, or are there differences when it comes to scaling, power efficiency, performance, or cost?
Yeah, I think here you come to an interesting point, which is, I would say, one of the killers of the whole thing. So if we talk about centralized AIs, and here we have a lot of compute power and, of course, many use cases which are running on central cloud already. So that means that there was a lot of investment done in the past, and there's still a lot of investment done right now and in future. So here, maybe the sheer performance, and also the, let's say, execution of super powerful training applications is a key to provide. Here we can see very expensive equipment like let's say computing systems or server systems which are based on thousands of GPUs, very expensive GPUs, and also related HBM, high performance memories, or even DRAM. So that is really a matter of fact that here the performance is a key. And for this, you have to pay very, let's say, very much to gain performance and to, let's say, fulfill the requirements of the applications. On edge or even endpoints, here the story is more differentiated. So here, basically, the cost is getting an issue. I mean, as we are going down to consumer products here, we have to make sure that the bill of material is still under control and the cost is limited. So here, definitely, we have to consider different concepts. Also, consider some kind of hybrid activities, do the training with high performance requirements, maybe at the central cloud, and do the inferencing with a more, let's say, compact and compressed bill of material into the edge, and then create a hybrid system, which is then, in terms of cost and in terms of cost performance balance, is capable to survive in the market, to be competitive in the market.
Mm. And I'm interested to hear, with AI models becoming more sophisticated, how are hardware advancements keeping pace? Are there specific breakthroughs in memory or processing technologies that you think are key to enabling these AI workloads?
Yes, I think there were already breakthroughs based on GPU developments, as already mentioned here. the GPU is offering the ultimate compute power, which is necessary for central compute and for running powerful AI applications and workloads. And I would say the scaling of huge data and also the more and more complicated and long-lasting training, which might take months or even several months or weeks and several months for one training session, is getting very critical. So you can imagine if this training stops due to some malfunctions, then you have to basically start the training from the very beginning, which is then very costly and basically not really acceptable. So here, several new concepts are on the table to be checked. Keyword is, for example, creating checkpoints, means to do intermediate offloads of training information. So just if a training is interrupted, then you can start from an intermediate point to save time rather than to start the training from the very beginning. So that is one of the very important parts of concerns of the advancements which have to be considered to improve future processing performance.
And speaking of important topics and important concerns, how do security and data privacy concerns shift as more data is processed at the edge and endpoint?
Yeah, also a very, very important point here. I mean, as you said, so this kind of AI-based applications are basically starting from cloud and from central compute power, where I mean the handling of data is getting very, very critical, especially if we talk about data privacy. And I think this is pretty much depending on the individual regions. So if you talk to let's say to US, or you talk to the Far East, or you talk to Europe, then maybe the expectations and the handling of privacy or data privacy is handled in pretty different ways. So I would say, considering Europe, I would say here we can see a pretty much conservative approach, especially talking about sensitive applications like, let's say, supporting banks or supporting industrial applications, or even justice and public applications which have to be protected. So I think here the data privacy is a big concern, and for this, I think several new concepts have to be brought up and to be considered. One thing which we also have in mind is, for example, to separate the sheer compute and let's say the storage of critical data, so that we separate based on maybe one unit which is just doing the operation and the other unit which is doing the storage. And then we separate it based on, let's say, super high speed optical lines, which are capable to let's say separate the compute and the storage units with maybe up to 100 meters. And we developed already optical storage drives, which are now evaluated on real systems. And so this might be one of the solutions to cope with the future concerns around data privacy.
Mm-hmm. Okay. And another important topic in terms of scalability, how do companies balance the need for powerful AI processing capabilities at the edge with the desire to minimize footprint and energy consumption? How does that impact memory selection?
Yeah, if we talk, you talk about power consumption or energy consumption and sustainability?
Yes, yeah.
Okay, yeah. I think this is also a very, very important point. And if we talk about the central compute, as already mentioned, this is really surviving based on a super high performance, and super high performance is directly related to high power consumption. And here, as the scaling and let's say the power performance is really a key, then especially in cloud, this topic has to be considered seriously. And here, I think in all technologies, whether it is HBM or DRAM, to use low power DDR, low power DRAM instead of DRAM, also in terms of, say, reduction of power by utilizing flash memory partially instead of power-hungry non-volatile memories, volatile memories. then flash might be a solution which is then consuming much less energy. So in any case, I would say the concern around footprint and energy consumption is a key to overcome. And therefore, this will be a major topic to solve in near future.
So as AI evolves then, Axel, what advancements do you foresee in edge and endpoint hardware over the next, say, 5 years?
So I would just come back to, let's say, the statements which I made before. So basically the trend is we established AI and AI implementation on this central cloud. And based on this experience and also, let's say, awakening the demands and the opportunities to utilize AI on edge and endpoints, this is really driving more and more implementation of AI in the edge. And so, as I said, data is then also moving from central AI to more and more edge and endpoints. So we talked about let's say the space applications and let's say our approach on approval of our technology in space. And this is basically one of the nice examples of edge performance or edge compute. We have other applications like portable, like mobile phone applications, which are already in place, and so which already accelerates the move from central AI or cloud-based AI towards the edge and endpoint. Here we have a couple of concerns like coping with the form factors. Also, as we mentioned, talked about power consumption. We have things like real-time applications, and furthermore, especially in Europe, we see ADAS or automotive and ADAS coming up to speed. And if this is then growing more, then also the requirements in edge and endpoints will grow further. So brilliant. That will be, from my viewpoint, the trend for the next coming 5 years.
No, brilliant. Thank you. Some good insight. And before we finish the conversation then, is there anything else that you'd like to discuss?
Yeah, well, maybe I can just conclude a little bit.
Yeah. Yes, please.
Mind. Okay. I would say conclusion from our side, from our perspective, is more or less that AI is obviously one of the fundamental enablers of innovation to find answers on the big question marks of sustainability and medical healthcare and treatment, or even other scientific topics of the coming future. And I think, as I mentioned earlier, theory and implementation of AI has already a very long history. But the big blockers were basically, in the past, the, let's say, the availability of technology, or not availability, or limitation of available technologies. And so nowadays, I think the demands of compute power and memory scaling can be properly fulfilled by new innovations of new flash technology, new DRAM technology. And so I would say today the situation is much better, and the industry step by step can overcome the limitations, also based on implementation of new powerful products mentioned like GPUs, HBMs, and DDR DRAM technologies. However, the balance, I think that is very important. The balance of required performance and related cost will dictate the speed of AI adoption, especially looking to migrate central cloud to edge and endpoint. And based off the tremendous pace of newly upcoming innovations, the industry, especially suppliers, have to be continuously awake and carefully monitor to align with the needs of new future developments. And with our efficient and sustainable 3D big flash technology, we want to help paving the way to hopefully bright and hopefully also positive future with AI. So
yeah,
I
definitely.
think we are ready for the race.
Yes, of course. And it's certainly a very exciting industry to be working in at the minute. So thank you for taking the time to share your insights with us, Axel. It's been a real pleasure speaking with you.
It was also a pleasure for me. Thank you very much.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry. Electronic Specifier.